All right, welcome to Designing an Optimized Universal Bias Circuit. Things are about to get super cool. And if this video is confusing or not clear, go back and review all the other biasing videos. Okay, prior to this video, we've been looking or approaching circuit analysis or the DC bias analysis assuming that the circuit's already been designed. We're looking at something that's already there and we're analyzing something that already exists. And all of our formulas have been based on that. Now we're getting to the fun stuff where we're going to start designing our own circuits. And this is a universal biased optimized circuit, and in order to be optimized, we want our VRC to be 45% of VCC, we want our VCE to be 45% of VCC, and our VRE to be 10% of VCC. So optimized should be 45, 45, 10, and that's our VRC, VCE, and VRE. And we also need to, right now we're designing our DC bias circuit for an amplifier. But when you design that for a common emitter amplifier, prior to designing, you would have a known load that this amplifier is going to see. And based on that load resistance, we'll use that load resistance in future videos to determine our RC. And so that would establish our RC based on our load resistance. All right, so now that we've established our RC based on whatever load we're going to use, we can find IC. VRC divided by RC will give us IC. And once we've got IC, we can divide IC by beta to get IB. And once we've got IB, we can times IB times beta plus 1, and that gives us IE. So now we know we've got 10% of the voltage across RE. We've got voltage and current IE, so we should be able to find RE now. So next, let's take a look at our IR2 and R2 on that resistor down there. So in order to maintain a real stable biasing circuit, we want our IR2 to be at least 10 times bigger than our IB. So now we know IR2, and using Kirchhoff's voltage law, we can Kirchhoff and see that VR2 is equal to VBE plus VRE. And so R2 should be equal to VR2 divided by our IR2, which is 10 times IB. Now that's going to give us a resistor value that is probably not a standard value. So you're going to want to round that number down and to the next standard value, and then you'll see that IR2 will go up. And so and that's fine because we want IR2 to be at least 10 times bigger than IB. So if it's bigger than 10 times, that's fine. So now we can see and use Kirchhoff's current law. We can see that IR1 is equal to IB plus IR2, and that VR1 should be equal to VCC minus VR2. And then now we can calculate R1 by dividing VR1 by IR1. Okay, so now we're going to develop our DC load line, which our VCE should be at 45% of the VCC or cutoff voltage. And we're going to see why that's important once we get to amplifiers and we start building the AC load line.